All right, so we have up to this point kind of started with what drawings should actually look like on as far as our working drawings, and covering how to go ahead and create them, both as far as the pictorial drawings with the isometrics and the orthographic projections that would be commonly used on um, manufacturing prints. So now we're going to start to go over and learn more about dimensioning and the importance of dimensions. Now, as I go through, and we will talk about this, there's a lot of information that is told to the manufacturing company in the way a dimension is placed on a print. And there's a lot of um, ideology here that if you know how to read it, if you know how to actually dimension the print correctly, you're basically telling and giving importance to one feature over another in the way prints are actually dimensioned. So, and for somebody who is new to this, that of course is one of the hard things to kind of get familiar with and understand the complexity behind actual dimensions. So let's kind of start here. Of course, we're going to, main reason for going through this is so that you know how to correctly dimension orthographic projection and that you're using the right techniques as you go through. Again, remember how you put a dimension on a print affects the way a part is manufactured. So I mentioned it before. For the machinist, for the technician, for the person who is actually manufacturing the part, if the print is drawn correctly, all the information that they need to know in order to make that part is there and shown on the actual print. So you want to make sure that you have a good understanding of this in the design process and what that's going to transfer over when you send your part designs or your manufacturing designs over to have them made. So we talk about orthographic projections where it shows the shape description of all of the objects. Of course, when we have the orthographic projection, it gives us the best way to present all of the information that's needed through the multiple views that would be being looked at. So we've got to kind of now take a look and as we start to dimension this, how can we dimension the part in a way that is going to still continue to bring clarity and not add confusion to the from the viewpoint of the reader of the print. So here's a couple of detailed examples so you can kind of see how this is laid out with the dimension. Here, of course, we've got the front view angles. Notice the gap in the extension line. So we will also be talking about and making sure that we understand what all of these different lines are that kind of represent the actual dimensions. But notice how neat and clear and concise this is. Notice how your eyes are sometimes necessarily drawn to one side or the other of a part based on what is popular or what's needed in the dimensioning technique from that. So as we go, so we when we draw and created the object in Fusion or Onshape or Inventor or SolidWorks, whatever we're using to actually create the 3D model in our software, we're putting dimensions in there. But we don't really use those dimensions when we go to create the drawing. So they're not necessarily quite the same as the dimensions that are required to manufacture. And of course, manufacturing follows accepted standard called the ASME Y145. So, and we need to pay attention to that. Of course, this relates to the 2009. So I think that's the latest revision of that particular standard. I think that standard's about to be put in the review process. But know that those standards do get reviewed every so many years. The ASME is the American Society of Mechanical Engineers. And there are groups that get together to kind of review and make sure that these standards are cohesive for the industry. So here is the tolerance and projection block. So this is important to know. Most of the time, these title blocks these are part of the actual title block by the company, and the company puts their standard tolerances, or what I typically call an implied tolerance. So notice how there's a 2-place plus or minus, 3-place plus or minus, tolerance on angles, and then it's specifically telling the print reader what the standard is that they're using. And of course, this is referencing third angle projection here. So we'll talk more about first angle and third angle projection and what that means as we go through the class. So what really is the goal when you're dimensioning a part? Of course, as we think about dimensions, we think about the fact that they should be very clear. So we want to be concise. They should, and we should have enough dimensions, again, that fully define the part. So it includes everything that's needed so that the person who's going to make the part and inspect the part knows exactly what they need to do, and nothing is left up for chance or second guessing on what the design intent or the meaning behind certain features on a part are. So as far as making sure that you do proper dimensioning, there are rules here that have to be followed. So that's kind of what this chapter is going to be all about, is helping you to know and understand what some of the rules are, and that you're following the rules when you actually go to do these prints. So you do need to know about what the appearance of a dimension is, how to use dimensions and locating of features, and then the additional rules that apply to our dimensioning techniques. So we're going to start here with the appearance of a dimension. So as you can see, we are going to use dimension lines, extension lines, and leader lines when we do these. Now, if we were typically board drafting with this, they asked me why 14 standard basically has 2 line type thicknesses. One is either thin or thick. So in case of all 3 of these line types, they are a thin line. So they're thin lines, so they won't draw or won't be confused with other visible object lines that would be on the drawing as well. So here's our dimension lines. So now notice when we put the actual dimension lines, so this is the dimension line here. So we have a feature size in the middle. So that's our actual dimension, what they're calling a feature size. The dimension line has the arrowheads on both sides of the line, and that dimension line points to the extension lines. Now the extension lines are coming down, and of course they're named extension lines because they extend from the edges or from the points or from the features that they are actually providing a dimension to. Notice it is also important to have a visible gap between these. Now we're going to talk here, and we're going to demonstrate when we start to apply these dimensions the importance of selecting the right line or the right point or the right feature in order to make sure that you have this gap. Because if I started down here and if I clicked on the length of this line to dimension it and then dragged it up, I would not have a visible gap. So you got to pay attention to where you're pointing, clicking when you go to place these dimensions. So again, the dimension line is broken right here in the middle. That allows for the feature size or the actual dimension to be placed. So our extension lines, of course, the thin solid lines that extends from the point on the drawing to which the dimension refers. So now we're also talking here about a leader line, and there are several ways that leader lines can be used. So most of the time, and the vast majority of the prints that I've experienced, the leader line is always going to have an arrowhead on it. It's going to come up at an angle and going to have kind of a tail on the side. Now, right behind that tail is going to be some type of a value or a note or something that tells you and gives you more information as far as what that leader line is pointing to here. So we do have that. Now, a couple other types of leader lines are where they would have a kind of a dot on the end, again, it's still going to kind of come up or be positioned at an angle and then go to a horizontal line that basically kind of has the note attached to it. And here, there are certain rules. Sometimes you might see it where it's just kind of touching more or less the feature that they're trying to call out and bring attention to. So they may be terminated here, as it's saying. This is kind of what I just went over. So with the arrow, it might have your dot or nothing at all on it, and that's what they are referring to as a termination here. So you have the arrowhead termination, the dot termination, or just the line termination if it's specifically pointing in inside a feature that it's looking at. So as we go with the leader lines, again, some of the rules here that we're going to use: avoid crossing leaders, avoid long leaders, avoid leaders that are parallel to adjacent dimensions, extensions, or section lines where they might get confused with those dimensions. And of course, note that small angles between the leader and the terminating surface should also be avoided there as well.